Hello, welcome back. In this video, I will explain set and its common uses. I will use online C++ compiler instead of using STMcube32. For that matter, you can use any online available IDE. It is easy to show output with online compiler. Set is a container. It stores unique elements or objects. It provides efficient method to sort elements. It provides efficient method to check whether element is a part of set. It provides efficient way to remove duplicate elements. This property of set make it unique for some use cases, for example store IDs, even for the embedded system, provided dynamic memory location is allowed in your project. So let's start. To make use of set, you have to include the header file set. Let's create set. You can use standard iterator to iterate through set. Let's try that. So I have created set with value 10, 20, 10, 30 and 40. And you can see in the output 10 is only one time. As I mentioned earlier, set store unique elements. It removes the duplicates. Set provide different methods and we will look into this method now. Let's start with the size. Size return the size of the set. And size of set is 4. Next method clear, which clear the elements inside set. Okay, here I am clearing element inside set and let's see what iterator returns. For the simplicity, I remove the first iterator output. After clear, there is no output value because set is empty. Let's try to insert element in set. Here I am inserting value 50 to the existing set and then iterate through the set. Okay, now set consists of value 50. Next method is erase. Here I'm reinitializing the set. Then erase only single element from the set. Check output. Okay, then after erase you can see 50 is no more part of the set. Erase method can be used in two ways. It can delete the single element as well as set of the elements. Let's try to delete set of elements. Here I'm using find method. We will discuss about it later. It returns the iterator. So it returns the iterator pointing to the 30 and I'm erasing the element starting from value 30 to the end of the set. For simplicity, I want to remove something. Okay, let's remove this part of the code. Okay, good. So definition of set, then deinitialization, then erase only one element, and then erase elements starting from 30 to the end of the set. After execution of this piece of lines, expected output is 10 and 20. Okay, here you can see value 10 and 20 are output. Let me make some more changes. So change introduced by erase with the find method are clearly visible. Yeah, and you can see after erasing values starting from 30 to the end of set, output is 10 and 20, which is quite useful in some scenarios. Then let's delete it. Next method is empty, which is useful to check emptiness of the set. Here I check whether the existing set is empty or not, and created another set without initialization, and expected output is here second set is empty and first set is not. Let's try. Yes, first set is not empty and second set is empty. Okay, now let's try the find method. So as I explained earlier, find method return the iterator to the past element, and here what I'm doing, I check whether the element with the value 60 is present. If it is present, then printing here found with value, otherwise printing not found. 60 is of course not part of the set, so it should not be detected by the find method. Let's try. Yeah, not found. Let's ignore the warning for now. Then I 10 and 10 is 10 found. Okay, then two last method, lower bound and upper bound. Let's check one after another. Here I have reinitialized the set, and lower bound method return the first value which is greater than the expected value. So in this case 60 is the first value which is greater than the 55, so it will return 60. Let's try, and output is 60. Then there is another method, upper bound. And upper bound return the value which is greater than the expected value. So I pass here 70. In this case expected output is 80. I'm sorry. Let's try again. So upper bound return value 80, which is greater than 70. You may be wondering what happened with if 70 is passed to the lower bound. Let's try. It will return 70, not 80. Yeah. So it returns 70. So lower bound return the first value which is not greater than the pass value, and upper bound return the first value which is greater than the past value. Then there is a last use case which I found pretty useful for the embedded system. to remove the duplicate and create sorted array. So set can be used effectively in the scenario where you have array or any other container with unsorted value and duplicate, but your expectation is you wanted to have non-duplicate value and sorted. Again, you can see here line number 9, array with duplicate and unsorted values. Then set is created from it, and line number 12 to 15 is iterating through the newly created set. Okay, to use array, I have to include header file. Yeah, so the set without duplicated value and all sorted. That's all for this video.